All right, so today we're going to dive into one of the other things that students tend to like least about math class, and that's story problems. But hopefully we can develop a little bit of a process here to make these go a little bit smoother for you. And so let's dive in. And so the point here is to be able to set up equations, right? Yeah, I know that a lot of story problems you can kind of common sense your way through and just sort of figure out what the question's being asked. But algebra is designed to make things a little bit easier, right? And so we want to be able to set up equations to model certain situations. And these story problems are a glimpse into how algebra can be used in your everyday life. So we want to try to use algebra as much as possible. So we've got to get into writing equations, defining variables, and trying to do the problems that way, right? All right, so here is our process. When we approach a story problem, you're welcome to mark up those story problems in any way that makes sense to you. Here's a recommendation, and I'm going to try to get you guys to do this so that these story problems become a little bit easier. So when we read through a story problem, the first thing we're going to do is underline the question. Understand what's being asked, right? Maybe even make some side notes in the margin about how to find it. Then we're going to go through and circle all the important values. And not everything in a story problem is important. But we'll talk about that. Now that we have that together, we want to go back to what we're trying to figure out and start defining some variables, right? And X is what we typically use, but you're welcome to use whatever variable makes sense. Because, and the variable needs to be specific. What exactly is it that that variable is going to let us know once we solve for it? And the hard part, setting up the equation, right? And we'll offer up some different types of story problems and some different thought processes that will help us set up equations. Okay? And then we'll solve, of course. We're going to look at our answer the question, and make sure that our answer makes sense, right? If it doesn't make sense, then we probably need to go back and take a look at what we did to get it. And then we always want to include our answer as a complete sentence. Okay? All right, so let's try putting this process to use. First problem. The bill for the repair of your car was $390. The cost for parts was $215. The cost for labor was $35 per hour. How many hours did the repair work take? Okay. Underline your question. How many hours did the repair work take? Okay? All right. Let's go through and circle some important values. Well, the 390 is definitely here. The 390 was the total for the repair, right? So maybe it's important to understand that the $390 represents the total. The 215 was the cost for the parts, right? And the $35 per hour. I would argue that that entire phrase is important. That was the cost for the labor. Okay? Okay, so now we're back to variables, right? What do we not know? What do we need to know? That kind of thing. How many hours did the repair work take? So, number of hours. We don't know how many hours the repair work took, so that's what we're going to try to find. You can let that be whatever variable you want. Sometimes it's nice to choose something other than X so that when you solve for it, it reminds you what it is you're trying to find. And so we'll let that be H, right? Okay. The equation. Well, I see that we have a total here. A total means that we've added a bunch of stuff together, and that's what we got. So we're going to set our equation equal to 390. And that was the total cost. So that means that we got to figure out where all of the cost was coming from and add those together. Well, the parts were $215. So that was one cost. And then the labor. The labor was $35 per hour. And the reason why I wanted to circle that whole thing was because it had this word per in it. That word per, if you go back to day one of class, suggests that you're going to multiply some things together. So we're going to multiply 35 times the number of hours, which we don't know, which is H. And we're going to add those guys together. right? So 35h plus 215 equals 390 becomes our equation, and now we can go solve it, right? Just subtract 215 from both sides. You get 175. Then divide both sides by 35. And h ends up being 5. And so h is the number of hours, and so what this means is that it took 5 hours to repair the car. Does 5 hours to repair a car sound reasonable? And hopefully it does to you. What might not sound reasonable, for some reason you mispunched in some numbers and you got like 50 hours or 500 hours or something like that, 292 hours. That's a long time to be working on a car, right? So you just want to check your answers, right? All right, so 5 sounds reasonable. Now we need a complete sentence. Answer the question. How many hours did the repair work take? Well, the repair work took 5 hours. Boom, done. That's it. Okay? So hopefully that helps make this make a little bit more sense. All right? Now, we have a series of story problems here, and the issue with story problems is that everyone is different. So I could show you 100, but the 101st story problem might be different than the previous 100. So just getting some good experience in is good too. So let's go through these. At some point, I'll just let you kind of mark it up and come up with the equation, and then you can start trying to figure out and start up the video, and you can kind of check your work, right? But let's go through the process again. Printing place will print business cards for 10 cents each plus a setup charge of $15. The card creator offers business cards for 15 cents each with a setup charge of $10. What number of business cards cost the same from either printer? So what number of business cards cost the same from either printer? That's our question, right? Now, I see this, costs the same, right? The same means that we're going to equal something together. So we want the costs from each place. The printer place and the card creator needs to be the same. So I'm going to make that note off into the margin, right? I want those to be equal. Well, okay. So now we want our important values. Well, there's 10 cents each, 10 cents for each card, and that's from the printing place. That's the first place, right? And then there's a setup charge of $15. Okay? So this is a cost, and this is a cost from the same place. So maybe we need to add those together, right? The card creator. Let's see, there's 15 cents each. Again, each card. And then a setup charge of $10. Right? But this is cost, and this is cost. Right? For the card creator. All right. So those are our important values. There are phrases, there are words of each in here, and that's going to indicate that we're going to multiply some stuff together. So let's go through and see if we can't set this up. Now we need to know what number of business cards. That's going to end up being our variable, right? So B stands for the number of business cards, and you always want to be specific when you're defining your variable. All right. So we take this and bring it down. The printing place cost needs to equal the card creator cost. Where does the printing place cost come from? Well, there's this and there's this. So there's $15 setup charge plus 10 cents each card, which means that we're going to take 10 cents and multiply it by the number of cards, which is just going to be 0.10b. And we kind of do the same thing with the card creator. There's a $10 charge for the card creator, and it's 15 cents each card there. Right? And those two need to be equal. So our equation looks a little bit different than the first one. And then we just solve, right? Collect your b's on both sides by subtracting 0.1 or 0.10b from both sides. Those add to 0, which is the whole point. You get 15 equals 0.05b plus 10. Subtract 10 from both sides. You get 5 equals 0.05b. And then divide both sides by 0.05. and B ends up being 100. 100 business cards does not seem out of the realm of possibility, so that makes sense. So it would take 100 business cards for the two costs to be the same. And you can find other ways to word this as long as it answers the question. Okay? It would take 100 business cards for the two costs to be the same. All right? Okay. Let's try our strategy first on the next one, right? Go ahead, read the question, read the problem, underline the question, mark up all the important numbers, and label them or do some margin notes if you feel like you need to, right? Stop the video. I'll do the same thing, and then I'll show you what I did, and you can compare it to what you did. Okay, did you mark it up like this? Okay. Underline the question. It's asking for the cost of one shirt. So my variable X is going to be for the cost of one shirt, not the number of shirts. We know the number of shirts we got, right? All right. So everything is about cost. And Martha's total cost was $67. I circled the total there because, again, that's a word that indicates that we're going to add some stuff up and equal this number here at the end, right? Okay. So where does that cost come from? Well, it comes from bumper sticker cost and t-shirt cost. How much are the bumper stickers going to cost? Well, she's going to buy 4 of them, and they're $1 each, right? That's up there in the problem. 4 bumper stickers times the cost for each one, so you're going to do 4 times 1, which is going to be 4, right? But I want to talk about where that came from. And then I'm going to add to that the t-shirt cost. Now, she's getting 3 shirts, right? 2 shirts for her nephew, 1 for her niece. So 3 shirts. So I got to take that times the cost of 1 shirt to come up with the cost for the t-shirts. And we don't know the cost of 1 shirt. So let it be X, so 3X. So there's your equation. Subtract 4 to start solving. Divide by 3. X is 21. Again, X stands for the cost of 1 shirt. So $21 for a shirt makes enough sense. So you can say the cost of 1 shirt is $21. Okay? All right. Hopefully this is starting to make a lot of sense. Go ahead and read the setup for number 4. Do your marking up of the problem, come up with your equation, and then we'll solve it together. Stop the video and start it back up and see if you're doing okay. So here's what I did. How many pieces does Sally need to sell to break even? I made a quick note here that break even means that her cost and her profits need to be equal. That's going to help me set up my equation, right? My important values there, the $600 for the equipment cost. She makes $12 each. I highlighted the word each because that tells me I'm going to multiply some stuff. And then it costs her $4 each pizza to make it. So again, each is highlighted because it tells me I'm going to multiply some stuff, right? So my cost has to equal my profits. So we start with the $600 equipment cost. There are 2 different ways to look at this. Here's how I chose to do it. $600 for the equipment. She needs to make that money back up off of her pizza, right? Well, she makes $12 each pizza, so I'm going to let P be the number of pizzas. So she makes $12 off each pizza, so that's 12P. And it costs her $4 to make each pizza. So I've got to take that $4 out of the revenue, right? So that's where the equation came from. Now, you could have looked at it as $600 for the equipment and then an additional cost of $4 per pizza, and that would have to be equal to the revenue of $12 per pizza. and set it up that way. That would be perfectly fine. To solve this, you would have eventually had to subtract 4p from both sides and gotten to the same place, right? So anyway, either way, you're going to get 75 pizzas. So it takes her 75 pizzas to break even. All right? All right, next one. Even more different than the previous ones that we've done. So let's set this up together. A student is 5.25 feet tall, standing next to a tree. The shadow of the student is 20 feet. The shadow of the tree is 80 feet. What is the height of the tree? So, question, what is the height of the tree? Important values. The student is 5.25 feet tall. The shadow of the student is 20 feet. The shadow of the tree is 80 feet. So something that we can do here would be we can compare heights and shadows. Right? We've done that before too. We've compared things. We can do that here too. Well, all right, first of all, what's the height of the tree? That's what we're trying to figure out. Let h be height of the tree if you want to. Okay, so here's what I mean by we can compare some stuff. We can compare height to shadow length. If we do it for the student, it's going to be 5.25 over 20. But because the sun is going to hit the student and the tree the same way, that comparison should be the same for the tree. So I can set that ratio up to the height of the tree over the shadow length. And so we're setting up a proportion. And there really wasn't any other meaningful way to get to what we needed to go to. So there wasn't a total. We weren't setting two costs equal to each other. So in the absence of a better way to set it up, maybe try that. Right? Does it make sense to compare height to shadow length? And hopefully it does. Then you can cross multiply. You get 20x equals 420. Divide both sides by 20. So x is 21. That means that the height of the tree is 21 feet. Okay, the tree is 21 feet tall. All right, so introduce the idea of being able to set up a proportion if we're comparing some stuff. All right. Okay, here's another one. Go ahead and stop the video, try to set it up, and then start it back up, and I'll show you what you could have done. Okay, there you go. Story problem there. The clay horse is 1.5 meters tall and 2 meters long. The scale model is 18 inches long. How tall should it be? Right, so let h be the height of the model. And again, we can compare, right? Compare the height of the actual clay horse to the height of the model, so 1.5 to x. And that should be the same, because it's a scale model, it needs to be proportional. That's going to be the same as comparing the length of the clay horse to the length of the model. So that's where the proportion came from, right? Scale model suggests that everything should be proportional. We cross multiply, solve, and we find out that the model should be 13.5 inches long. Okay? All right. Next one here. A little bit different problem even still. So the formula A equals LW gives the area of a rectangle given the rectangle's length and width. Solve the problem for W. What is the width of a rectangle with length 14 and area 161 square centimeters? So this isn't so much a story problem as it is some of our literal equation stuff that we did last time, right? So area equals length times width. If it helps to draw a picture, you can do that here. That's one thing that we haven't done too much of, and it's drawing a picture. Could maybe have done it for the last two, but anyway. The length is 14. We don't know the width, but the whole area is 161, right? So it says solve the equation for W. Well, to solve for W, we've got to divide both sides by L. and we get A over L equals W. Now, you can plug in what you know. You know the length is 14. The area is 161 square centimeters. And if we want to find the width, we just divide 161 by 14 and find that the width of the rectangle is 11.5 centimeters. Okay, so that's a little bit more straightforward than the other ones. All right, go ahead and try number 8. Stop the video, then start it back up, and make sure you're doing it correctly. There you go. Did you find the width to be 39 inches? Okay, if not, find some time and come in and get some questions answered, right? But otherwise, homework's out in Canvas. Make sure you have this done by next time.